All right, let's try to walk you through a couple things on 22. And again, we're just making a story problem out of something that we've already done. So it's just making sure that we get the information put down. But in the Department of Education at UR University, student records suggest that the population of students spends an average of 5.5 hours per week playing organized sports. The population's standard deviation is 2.2 hours per week. Based on a sample of 121 students, Healthy Lifestyles would like to apply the central limit theorem to make various estimates. So it says compute the standard error of the mean. We haven't really talked about that, but we've been doing it anyway. So the standard error is just the bottom part of that equation, right? So the standard error is the bottom part of the equation, that it's the standard deviation divided by the square root of n, whatever our sample size is, okay? And so our first one is just to do that. Well, okay, our n, we got to take the square root of. The square root of 121 is 11. Standard deviation is given to us, 2.2, so we get that. Okay, so I've kind of done A for you, right? Okay, and I've actually done the first part of B for you here, right? So we just plug in our information. It asks between 5 and 6. So we're right at the center there, right? We're looking at, at this area, kind of in here, big tall area, right? Okay, but let's take a look at it. And it says we just do our math then. So we've got our first mean is 5, or not our first mean, but our first x value is 5, and our second x value is 6. So 5 minus 5.5 minus 0.5. Our standard error of the mean, or the bottom part of the equation, is that. So our z is that. Okay, that's a big z number, right? Okay, 2.5 full, what do I want to call it? 2.5 full standard deviations that have been corrected, based on the sample size. Okay, that's a long way. So my number is going to be a big number, right? When I get there, it's got to be less than 1, but it's going to be a big number. Okay, then you got to take a look at the other ones, and again, you're, 5.3 and 5.7 going to be a smaller number, right? And then greater than 6.5. Yeah, you can kind of take a look at where 6 would be, so you should have a pretty good idea that 6.5. Yeah, I'll let you guys figure out the rest of it. There is number 22.